All right, now we're going to be talking about electron domains and the shapes of molecules. Keep in mind, even though we've been drawing molecules on paper and their structural formulas, it's been very flat, very 2D. But what you have to remember is that molecules are very 3D, and they do have different shapes depending on the molecule. But first, an electron domain is the space occupied by pairs of valence electrons, whether they're bonded pairs or lone pairs. These electron domains affect the shape of the molecules. If you look at the first molecule on the left, ammonia, or nitrogen trihydride, we can see that it has 1, 2, 3, 4 electron domains. Okay, so 4 areas where there's electrons. If you look at the one on the right, methane, or CH4, carbon tetrahydride, we also have 1, 2, 3, 4 electron domains, 4 spaces where there are electrons. Okay, both of them have 4 electron domains around the central atom, but they have very different shapes, as we'll see momentarily. What we have to look at first is what's called the valence shell electron pair repulsion theory, known as VSEPR or the VSEPR theory. In this theory, it states that the electron domains in a molecule adjust so they are as far apart as possible and have the same amount of space. You have to keep in mind that electrons are negatively charged, and so they'll repel each other. They don't want to be close to each other if they don't have to be. So they move around so they're as far apart as they can be from each other, but so they have the same amount of space. If you again look at methane, CH4, now we're going to look as if there's actually atoms there instead of just the letters to represent. These ones are equidistant from these ones, are equidistant from these ones, are equidistant from these ones. However, you have to remember these ones. These two are further apart than the others, so that's not going to be following this theory because they're not all the same distance and they do not all have the same space around them. So what actually happens is these electrons are going to shift so that we have more of a 3D shape. And if you were to look at this, and we'll be building them, they actually are all the same distance, following this VSEPR theory. This shape is called tetrahedral. So if you look at this chart, the first column is, of course, the name of the shape. The next column is the electron domains. How many spaces of electrons are there around the central atom? So when I say that, keep in mind that some molecules have many atoms, so we'll be focusing just around a section of it, a segment of it, focusing just on the central atom. And then you have to look at the bonded pairs around that central atom and how many lone pairs there are around that central atom. So the first one, tetrahedral, was the one we just did, CH4. There were 4 electron domains, all 4 of them were bonded, and there was no lone pairs. And so we have the tetrahedral shape. The next one is pyramidal or pyramidal. Also has 4 electron domains, but of those 4 domains, only 3 of them are bonded, and so you will have 1 lone pair. So if you look at this picture here, it's showing the lone pair of electrons. That's this little green section here. But when we're talking about the shapes of the molecules, even though these lone electrons, this domain, does affect the shape, we don't actually include it in the drawing of the molecules. So this is how trigonal, pyramidal, or pyramidal would look. Next we have bent, where we have 4 domains again, this time 2 bonded pairs and 2 lone pairs. So here we have our 2 bonded pairs and our 2 lone pairs. Again, in the shapes, we don't normally draw the lone pairs of electrons, So we just have the bonded pairs here. But we know these lone pairs are here, forcing this to be bent. Next we have what's called trigonal planar, and these ones are going to contain multiple bonds. That's why we have only 3 electron domains, but still have 4 bonded pairs. And usually there's going to be 0 lone pairs. Okay. Now if you notice, it might look similar to the pyramidal one, but these ones don't have that lone pair of electrons that would force these down into the pyramid shape that it is. So these are all on the same plane, which is why it's called trigonal planar. It would lie flat on the table. Okay, and last we have 2 sets of linear. If you notice the first one, we have 4 electron domains, but only one bonded pair of electrons, and so 3 lone pairs. That would make it linear. It could also be linear if we have 2 electron domains and 4 bonded pairs of electrons, leaving 0 lone pairs.